Let's look at a hanger problem together to try and solve it using an equation. In this example, a triangle weighs 3 grams and a circle weighs 6 grams. Number 1 says find the weight of a square in hanger A and the weight of a pentagon in hanger B. Write an equation to represent each hanger. Well, let's just focus on hanger A for right now. All right, so let's talk about what we know. We know that a triangle is 3 grams, a circle is 6 grams. We don't know what a square is, so let's use a variable to represent the square. And we have one more circle here, which we know is 6 grams. Now, over on this side, we start out with a whole bunch of squares. So let's just name them each X. And we have another circle, which we know is 6, and one more X. Okay, so from here, we can now make an equation and talk about our figure. So we know that in our hanger, the left side is going to be equal to the right side. So I'm going to start out with the left side. We have 3 plus 6 plus 6 plus x plus another 6. We know that is equal to, well, rather than writing all of these x's, I know there are 1, 2, 3, 4, 5 of them, so I know that that's the same thing as 5x. And the only other thing on the right-hand side is one circle, which I know is 6. So let's simplify the left-hand side a little bit. We know there's a 3, a 6, and a 6. Those are all like terms because they're all numbers. So 3 plus 6 is 9, plus 6 is 15, plus another 6 is 21. So we can say that this side simplifies to 21 plus x equals 5x plus 6. Now let's come back over to our diagram. We learned in the last activity that if I remove the same figure from both sides, I should be able to keep the figure balanced. So I notice that I have a circle on the left and a circle on the right. So I should be able to just get rid of those. So let's get rid of those 2 circles. Now, the same idea happens with this square and one of my squares from here. So let's get rid of these 2 squares. My hanger should remain balanced. So now let's see what I have left. Now over here I have a 6, and a 3. I know that that's 6 plus 3 is 15. So I'm going to say that the left-hand side now is equal to 15, and the right-hand side is equal to 1, 2, 3, 4. So 4x. Well, how are these two things related? If you start to work on balancing equations, you can see that if I were to bring all of my variable terms to one side of my equation, I have 1x on this side. Let's add in that 1. And I have 5 x's on this side. So I can subtract 1x from both sides of my equation, and I end up with 4x like I have over here. So now I'm left with just 21, my positive 1x and negative 1x or zero pairs, so they disappear. And I know that 21 equals, again, 5x minus 1x is 4x plus 6. Well, now I remember from 7th grade, I have a two-step equation, so I can subtract the 6 from both sides. And then I end up with 21 minus 6, which is 15, which is what I found over here by adding up my circles and my triangle. So I end up with 15 equals 4x, and now I just need to divide by 4 on both sides to get my x by itself. Now, to do that, I might want to use a calculator, and that's okay to do, because here I need to figure out what 15 divided by 4 is, and that doesn't divide evenly. So if I plug these into a calculator, I end up with x equals 3 75/100ths. And because I was talking about grams in my original equation, I'm going to add my label of grams here. All right, go ahead and give B a try.